So in this video, we're going to start talking about the idea of molecular weight or formula weight. So remember that we draw we give chemical formulas that represent how that chemical compound has come together and gives us the ratio of elements in that compound or the number of elements in that compound. So here, if we look at this, you have calcium and you have 2 chlorines, or we have carbon and we have 2 oxygens. So based on the fact that we know the chemical formula for these different compounds and that we can figure out the weight using the periodic table, we can figure out the weight of an entire molecule or an entire formula unit. So a molecular weight or a formula weight is just the weight of one molecule. So remember, if we're dealing with molecules, that means we're talking about covalent compounds, or the weight of one formula unit, or Fu, and that is an ionic compound. But really, the principle is the same. We just call them something different because they have different names. So we're going to use the periodic table, and we're going to add up the masses from the periodic table to get the weight or the overall mass of the one molecule or one formula unit. Now, we talked about the mass on the periodic table, so we've got to remember that the mass given to us on the periodic table is a weighted average, and it's protons plus neutrons. So from the periodic table, the mass that we have is in AMUs, or atomic mass units. So let's just go ahead and start figuring some of these out. So when I do this, what I like to do is I like to write the symbols or the elements that I have and list how many I have of each. So I have calcium and I have chlorine. Calcium, I have 1 calcium and I have 2 chlorines according to my chemical formula. Then I'm going to go to my periodic table and I'm going to see that calcium is, let me zoom in a little bit so you can see that. Calcium has a mass of 40.08. I'm going to round that to 40, just assuming that we have the most common isotope. Then if I want to take a look at chlorine, chlorine is 35.45, so I'll just round that to 35. It's simple. And 1 times 40 is 40, 2 times 35 is 70, and then if I add those together, I get 110 AMUs. This is the formula weight of calcium chloride. Now, the reason why I call it a formula weight and not a molecular weight is because calcium chloride is an ionic compound, so this is a formula unit. All right, let's try another one. So carbon dioxide. Carbon and oxygen are both nonmetals, so I'll be calculating the molecular weight of this. However, I do it in exactly the same way. So this is a molecular weight. So I have 1 carbon, I have 2 oxygens, and I'm going to look on the periodic table and see that carbon has a mass of 12, and that oxygen has a mass of 16. So 1 times 12 is 12, and 2 times 16 is 32. 32. If I add them together, I will get 44 atomic mass units. Right? Now let's do one that's a little bit more complicated. So if we look here, I've got a hydrate. So it's copper sulfate pentahydrate, and it's copper 2 sulfate pentahydrate. Now we consider this a formula weight because this is an ionic compound. So I'm going to make a list of all the elements that I have, and actually I'm going to keep water separate. So I have copper, there is 1 of them. I have sulfur, that is 1. There's oxygen, that is 4. And then I'm going to say that I have 5 waters. Okay. And the reason is we'll see in later videos that a lot of times water is treated separately, and we look at calculating water in terms of, um, how much water is in a compound. So we like to keep it as one whole thing. So if I take a look at the formula for water, that's 2 hydrogens and 1 oxygen. So each hydrogen is 1, which is 2. Now I got that from the periodic table. And remember that oxygen is 16. So the overall mass of water is 18. All right. So what I'm going to do is I'm going to go ahead and then list. I've got copper, which is 63.55. I'll round that to 64. And then I've got sulfur, which is 32.07. So 32. Oxygen, which is 16, and then I'm going to say that I have 5 waters, which are each 18. So I just add them up. So I got 64, 32, 4 times 16 is 64, and then 5 times 18 is 90, right? 50 times, yeah, 90, and then I'm just going to add all of these numbers together. Let me just pull out my calculator really quick. 64 plus 64 plus 32 plus 90, and I get my total mass of that compound is 250 AMUs. So that is molecular weight and formula weight.